So you may remember Young's double slit experiment that we showed with polychromatic or white light, but here we have a very similar setup now with coherent light, so that we illuminate with our laser a double slit or a single slit, as I will show in a second. You see here that there's a little mechanism that allows me to close one of the two lines, and so currently we just have a single slit here. But when I open this, then it will become a double slit. So this is a very nice demonstration also about how mathematically you can describe the diffraction pattern. So if you think about it, a single slit can be seen as a rectangle, and if we now look at the screen, you would actually see the diffraction pattern of a rectangle, which is, if in the amplitude world, is a sinc pattern. So what we see, of course, is the sinc square of it. And when I now change this slit here by opening it up, then you see a modification, and you see the same pattern has been now subdivided here. So in fact, it's a multiplication with a sine pattern. Why? Why that? Well, we have now a double slit, and a double slit is a rectangular pattern twice. So you can see it as a rectangular pattern convolved with two delta peaks. So that means here we have a convolution of a rectangle with two delta peaks, and here we will have the multiplication. That's the convolution theorem, the multiplication of the sinc pattern with the sine pattern, because the Fourier transform of two delta slit becomes a sine pattern. And of course, what we observe is the absolute square of it in the end.